So now we're going to look at some time, velocity, and speed equations and problems. So calculate the Earth's average speed relative to the Sun, and what is the average velocity over a period of 1 year. Okay, so the Earth travels around the Sun like this. And in order to know its average speed, we have to know the distance that is traveled. Okay, so the average speed is the distance traveled divided by time. Now, I know the time is 365 days. The distance I might have to look up as a fact, and if you look it up at Google or just figure it out or estimate a circle, whichever way you want to look at it, it's about 900. Google is telling me 940 million. That's times to the sixth kilometers. Now, suppose I want this, so you could do this in kilometers per day, but that's not a really common unit for speed. So we might want to convert this to meters per second. So first, this would be 940 times 10 to the 9 meters, because I multiply by 1,000 up there. And on this one, I do some dimensional analysis. 365 days times 24 hours in a day. And then I want to convert from hours to seconds here. And in 1 hour, we have 3,600 seconds. You could convert to minutes and then seconds. You would do 60 times 60. But you should get the same answer. And so we do this. My calculator, 900E9 divided by 365 divided by 24 divided by 3,600. Well, it's not 900, 940. Yeah, what I said, 940. I got 29,807 meters per second. That's pretty fast. About 30,000 meters per second. Okay, average, so that's part A. Average velocity is the displacement over time. Now, in 1 year, what is its displacement? Well, it came back to where it started. So its displacement is 0, which is just 0. So average velocity is actually 0 because it just kind of gets back to the same spot every year. That's not technically true. I think the sun is actually moving. Technically, it's orbiting the center of our galaxy. So technically, we probably did move a little bit, but we'll just assume that we don't know that, and it's just going around, and the Earth's sort of the center and not moving. Okay, number 7. North American and European continents are moving apart at a rate of about 3 centimeters per year. At this rate, how long will it take them to drift 500 kilometers farther apart than they are at present? So this is a velocity. Velocity is the displacement over time. And what are we given? We're given that the velocity is 3 centimeters per year. And we're giving, we want to know when the delta x is 500 kilometers. And so we want to find what t is equal to. So if I rearrange this equation for t is equal to delta x over v. Delta x is 500 kilometers. And this is 3 centimeters per year. Now, if you look at these units, it's going to be kind of weird. I'm going to get some kind of year per, like these aren't the same units. So I need to make the kilometers and centimeters cancel. So I'm going to convert everything to meters. This is 500 times 10 to the 3 meters. Right, 500,000 kilometers. 500 kilometers, 500,000 meters, and then 3 centimeters is 0.03 meters per year. And so then, if I divide this, the meters will cancel, and I'll get years as my answer. And that is 16 million years. 16.7 million years is what I got. So it's going to take a while. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.